All right, this video we're moving on to 3.3. We're only going to do one video for 3.3, and we're going to look at more properties of logarithms. The first three, we're going to use our TI Inspire just to evaluate these. And the great thing about the TI Inspire is that you can change the base for logarithms. Any other calculator, a TI 83 or 84, the base is always 10, but the good thing with the TI Inspire, you can change the base. Now, 1, 2, and 3, you can just put in your calculator and you're going to get a decimal for it. But I'm going to kind of put like some meaning and purpose behind it. If you had to evaluate number 1, I'm going to say this is equal to y. If I put this back into exponential form, I'll just write it. I'm going to write this here. I do the circle. This is 4 to the y equals the argument of 30. So I'll just write it up here. Now, if I look at this, I know, let's see here, 4 squared, I'm going to write this here, 4 squared is 16. And if we did 4 to the third, I'm just going to use whole numbers for the exponents. 4 to the third would give us, I believe, 64. Now, all this is saying, and all I'm going over here, this 30 is right in between 16 and 64. And it's a little bit closer to 16. So what that's telling is the answer for y, it's probably going to be closer to 2. So just put this in, log base 4 of 30, and when you put it in your TI Inspire, you should see that the answer, I'll use wavy lines because we're going to approximate, equals, or it's around 2.453. I mean, I could just say, hey, put it in the calculator, you get 2.453, and you forget the meaning of it. Well, here's the meaning of it. 4 squared gives you 16, 4 cubed gives you 64, and this 30 is between 16 and 64. So that means the answer has to be between this 2 and 3. Okay, 2 and 3, I'll just say, let's see here. So if I did this, if I put number 2 in exponential form, it's this, 2 to the y equals 14. Let's see here. 2 cubed, I know, is 8. And 2 to the 4th is 16. So 14 lies in between these. It's closer to the 16. So that means this answer, when you put it in your calculator, is going to be closer to 4. And if you put that in your TI Inspire and you put in log base 2 of 14, you should get this decimal. It's around 3.807. All right, number 3, if you put that in, your answer here for number 3. Actually, you know what, number 3, do this right now. We'll go over the answer tomorrow. The main idea is actually the properties of logarithms. There's 3 basic properties that we're going to use, and we're really going to use these for the next section when we solve exponential equations and logarithmic equations. All right, so I'm just going to give these to you. I'm going to write these out. And again, you've probably seen these before. You probably saw them last year. All right, this is called, number 1 is called your product property. U and V are going to represent numbers. If you're multiplying them, then you can actually expand this to say log base A of U plus log base A of V. Now, if you do the opposite, if you divide U and V, when you expand these into 2 logarithms, you subtract them. This is going to equal log base A of U minus log base A of V. And then 3 is called your power property. If you take an argument and raise it to the n, it's the same as just taking n and moving it to the side and multiplying the logarithm. So this is the same as doing n times log base A of U. They mean the same thing. So we're going to use these properties. We're either going to expand or we're going to condense. So we could either start out with something that looks like this and condense it to 1 logarithm, or we can expand it. And that's what we're going to do for the next problems here. Okay, we're going to do 4 and 5. This is where we're going to expand. So we're going to use the properties to expand. Now we have 4, 5, and 6. They're all written as 1 logarithm or 1 natural logarithm. We're going to expand it so it's a combination, whether it's addition or subtraction, of more than 1 logarithm. Okay, the number 1 thing you ask yourself when you do 4, 5, and 6, when you expand, you ask yourself, all right, are we multiplying the arguments, or are we dividing in the arguments? For number 4, it's clear. All of this right here, you're multiplying. 5 times x cubed times y. So that means I'm going to add all of these arguments. So I'm going to keep the base the same. I'm going to have log base 4 of 5. Then plus log base 4 of x cubed. And then plus log base 4 of y. So I'm spanning it to 3 logarithms because I'm multiplying 3 quantities for the argument. 5, x cubed, and y. Now the only other thing I can do, I can use the third, I can use the product property, not the product, the power property. I can move this 3 down there. So my final answer here is going to be log base 4 of 5 plus 3 times log base 4 of x, and then plus log base 4 of y. This is the answer here for number 4. All right, so the key there was you were multiplying quantities in the argument, so that means when you expanded, you had to add. Okay, I'm going to erase this, so make sure you have this down, and then I'm going to do number 5. Okay, so I erase all of this. Okay, and let's do number 5. Now, number 5, again, I asked myself, all right, am I going to add or subtract with the logarithms? We are dividing here, so that means I'm going to subtract. So when I do this, I'm going to have natural log of the square root. And I'm actually going to rewrite this as 3x minus 5. If you take the square root, it's the same as raising it to the 1/2. And then I'm going to put minus the natural log of 7. The easy thing to remember is whatever is in the denominator here, that has to go with the minus. It means you're dividing the whole quantity by that 7. Now the last thing I can do, I can take this 1/2 and move it to the side. So it's 1/2 times the natural log of the quantity of 3x minus 5. And then we subtract the natural log of 7. So I expanded this to 2 natural logarithms because there's 2 quantities I dealt with. The numerator, the square root of 3x minus 5, and the denominator, this 7. All right, number 6 we'll do in class. And then we're just going to do 7 and 8 on the video. 7 and 8 is the opposite. Now we're going to go backwards. We're going to condense it to just a single logarithm right here. Okay, and I'm going to keep the same base. This is going to be log base 10. Now here's the key. It says add. So that means I'm going to multiply these arguments, the x and the x plus 1. Now the other thing, this is 1/2. This is like saying x to the 1/2. And then we're going to times this by this quantity of x plus 1. You could leave it like that. I would accept that as an answer. The other thing you could do is you could just take that x to the 1/2. That's the same as the square root of x. And then times the x plus 1. You don't have to distribute because it's really not going to simplify anything to you. We're just basically, I'm just testing to see, do you know how to use the properties, whether to expand or condense. So this is it. That's your answer there. Okay, let's do number 8. Now number 8, I see that we are subtracting, so that means I'm going to divide. So I'm going to write this out as just natural logarithm. Now the x plus 2, that's positive, so that's going to be up top. And it's 2 times it, so it's basically like saying x plus 2 raised to the second power. And then whatever's with the minus is going to go in the bottom of the fraction. So we're going to divide it by x. And that's it. That's all you do right there. If you took this and expanded it, well then it's the original problem that you're given. So really, I would say the main basis of this video is to know these properties, how to expand them, how to condense them. You're really going to use these properties when we go into the next section to solve exponential and logarithmic equations. And then the other thing I showed you was the very first thing, 1, 2, and 3, that you really just use your calculator. And that's pretty much most of 3.3 is the properties and then using that to expand and condense.